Okay, we try to refresh what we focus on this subject first. At least you have some ideas ataupun to come to get the overall what we try to understand and learn in this subject. Sekejap kita cerita dulu. Okay, bismillah. Okay, so as far we know, this is our control engineering. So this is the subject of control engineering. What we will do in this subject, okay, you will to identify the system, our system, okay, the class of our system, or the type of our system itself. So we call control system. So as far we know, we only have in this subject, we only have the two category of system. We have open loop system, okay, and also we have closed loop system. Okay, so the difference between open loop and closed loop very easy, because of we all still have these two main element, which is we have the input, okay, normally we call U, and we have the output. Output, tak boleh tulis dah. Oh my god, tak boleh. Okay, boleh. Apa? Kejap. Tak boleh. Tak boleh. Kenapa tak boleh? Okay, boleh. Kenapa boleh sekejap tak boleh? So we have output. So we have output Y, normally Y, output. This is output. So this is our system. So the closed loop, we just add the sensor to measure, okay, measure our performance of the system itself, positive and negative. So this is the differential between difference between the output and open loop and closed loop. So from this, okay, understanding of the control system, our control system. So what we can do now, we try to come up with the model mathematics, because before we implement the system, we need to model first. Okay, to model first, because of what? Because of we need to understand the behavior of the system itself before we try to integrate all the component, the real component. So nak elak to get the safety factor and so on, to save budget and something. Okay, tu salah satu lah the factor. So need to come out the mathematic model. So we come up with the mathematic model. So I think you have some idea to come up with the mathematic model. In the mathematic model, we have several system. We have mechanical system, we have linear, we have hydraulic system, we have electrical, and so on. So we have subsystem, because of all the subsystem are related to the engineering application. So if we are in the mechanical itself, so we have the component subsystem. For example, we concentrate on the spring, mass, damper, and so on. So sama lah. So we need to come up with a mathematic model. So once you come up with the mathematic model, okay, you will get the ordinary differential equation. For example, you will get maybe mdx square whatever, okay, plus maybe cdx or cdx dt plus kx and so on. Okay, so from this equation you come up with the Laplace transform to get the S transform. So for example, in this system we have gh is equal to, maybe we have k S plus 1, okay, or maybe we can get GH, maybe we can get S equal to S plus 2 or whatever. Okay, so this system, this mathematic modeling system, you will come up with the individually equation component And from that you integrate, and then you come up with the general equation. We translate into the Laplace transform. Okay, so in the same time, what we can do is you can come up with the block diagram. So this is the block diagram what we have. Okay, we have created, and then from this block diagram you need to simplify. Okay, simplify to become just one. Okay, and this you have done in test 1, and also in final you will face this this concept to simplify by using Mason rule. Okay, this is you need to concentrate on this. So the question 1, they will ask you to model mathematics again, A, and B to come up with the Mason rule to simplify the block diagram to use the signal flow graph yang macam ni tu lah. Go up and go down, whatever, based on our block diagram. Okay, so from this, okay, you come up with this model mathematics and then come up with the block diagram, okay, to get as the understanding of the system itself. So you need to simplify to get the simple combination, all the related to the block diagram to become a simple block diagram. Okay, so from this, and then you will consider all the time response. So once we come up with the equation and on the fabrication of the theoretical by modeling, and then we concentrate on chapter 2 is the time response. So time response. Okay, time response. So time response means that you learn in first order system. First order system. First order system. Okay, first order system. So first order system, okay, you just come up with graph, kan? This is your done with test 1. So and then you concentrate on the second order system. Which is, okay, you will need to calculate the overshoot and settle time and whatever. We have peak 1, peak 2. This is you need to concentrate on question 2 final. So this must be, okay, understand fully before you get to the final exam. So this is, we have question 2. We will ask us, ataupun we will ask you to do some analysis on second order behavior in the system. So you need to remember the equation of the first peak, second peak, overshoot, peak time, whatever, any are related to the second order. Okay, so we have chapter 1 to understand the system. Second, chapter 2 is the mathematics model. And then from the mathematics model, we just come up with the time response of those time response of our system itself. We learn the first order system, we learn the second order system, and then you will get the class of this dynamic. You have the system, we have the order, we have the rank, class, whatever. And then also we concentrate on the steady state error, steady state error. So also in the final exam. So this is the chapter 3. So chapter 1 and chapter 2 is question 1 final. Question 3 is question 2 final. Okay. So okay, just now we are in chapter 4, which is we concentrate on the stability and root locus. They will call root locus. Okay, stability. So stability, we have done this. Okay, we concentrate on the root stability criteria, which is we have the table we call roof Hurrik. Okay, jap saya tengok. we roof array. Kadang-kadang ada some book we call roof array. Some book, okay, in the UTM mechanical book, we call roof array. Okay, we only concentrate on one characteristic equation equal to 0. Okay, some okay, term we have hurik apa nama dah dia punya tu, hurik ada lah dia punya tu, tak apa, biar dulu. So hurik, roof hurik ada setengah, some we call roof hurik table ataupun ni table, same, we concentrate on the characteristic equation. Okay, so we have we have table, we need to come up with the power of highest S, and then we need to reduce S. Okay, follow our characteristic equation, and then we will get a number of B and C. So normally we only fulfill the two line, the highest and the second highest line. Okay, based on our characteristic equation. So we just concentrate because of we just to make sure that to identify our system is stable or not stable. So if we have declare, or if we get our system is stable, means that all the sign is same. For example, if we have the sign is positive, mean that our system is stable. If we have the sign is negative, mean that our system not stable. Because of what? Because of we concentrate on, we call S-plane. S-plane. So this is our real, this is our imaginary. So where we only concentrate on the left hand side, because this is the area which is this table. But if we have the system is here, means that we not stable. Tak ada. We need to redesign our model again to get all the root of this system, it go to the left hand ataupun left side. Apa lah dia punya tu. Okay, so now apa yang kita nak buat adalah today, okay, once we finish this, concentrate on this, so we will try to draw, okay, or sketch the root locus, okay, based on our system itself. So now we are try to prove that our system is the condition based on this stability condition. So from this stability condition, so once we confirm that this system is stable, means that okay, we need to do some further study, then we try to approve ataupun we try to show the behavior of this stability condition go to the root locus drawing ataupun root locus sketching they call. Okay. Ada apa-apa soalan tak? You have anything you want to ask ataupun you have the question you want to ask? Boleh kelas? Ada setakat ni so far?
Apa? Okey lagi doktor.
Boleh lagi Apa lagi Abdul Rahman? Boleh? Kan?
Ya, okey doktor.
Boleh. Alhamdulillah. Okay, so kita tengok dulu. So now we try to come up with the some theoretical on this root locus. Okay, tak apalah ni nanti I will share this slide as well. Tak apa, biar dulu. So okay, so this is the root locus meaning. So we have the graphical. Okay, this is the sketching. Okay, this is the part of the sketching. We call root locus is based on the S domain. Mean S domain is S over S plus 1 or whatever. S maksudnya dalam bentuk S. S is continuous. If we consider as the Z is the digital. Now S symmetric. So tak apa, biar dulu. So apa kita nak buat adalah in this concept, okay, in this concept root locus, we need to follow several rules or several steps. So in some book, they will show you until 8 or 9 rule. Okay, some cases they will show you ataupun they will teach you maybe rule until 7. It doesn't matter. Once you do some exercise, you will know ataupun you automatically you follow the rules or the step in this how to design root locus. Okay, so this is the rule. Okay, you just don't make stress on this rule, tapi I will teach you one by one. So now the first rule is we need to identify our root. Okay, where is our pole, where is our zero, and then we need to understand the branch. Okay, never mind. After this, I will show you. And then we have the root 3, we have the stage 3, stage 2, stage 3, and so on. So okay, kita tengok dulu. We will try to come up with a simple example. Okay, simple example. Kita tengok dulu. Okay. For example, we have this system. Okay. Please take note. If we concentrate on root locus sketching, we always do this implementation using open loop. Open loop. We not concentrate on closed loop. Okay, for example, okay, I will show you some. I will show you example. Wait, okay, for example here. Okay, now our system basically this is the general form of our system. We have the equation of G. Okay, and also we have the equation of our H. Okay, normally this is we call feedback control. So we have U, we have Y, we have plus and minus. Okay, if we are trying to looking for the transfer function, okay, so the transfer function in this system is we have GH1 plus GH. Okay, this is the transfer function, the equation in this system. But if we try to design the root locus, we only consider a open loop. So means that our transfer function open loop is we have transfer function open loop, we only have G and H. Okay, for example now, so we have, for example, we have K maybe, and we have S, and we have S plus 1. So for example, katalah, sorry. Okay, so we have this, S minus, so U and Y. So from this, okay, the open loop in this system is we have KGH equal to, so we have K multiplied by S plus 1. Wow. Okay, so means that this is our system, and from this system you need to ataupun you continue to sketch the open loop. But okay, if we try to looking for the transfer function, this system is macam ni lah. So we have KGH and 1 plus KGA. This is the transfer function. And if you try to solve ataupun to looking for the roof Hurwitz criteria ataupun roof array, okay, you only concentrate on this part, okay, to get the stability table. Okay, but if you concentrate on the root locus, we only use open loop. Maksud kali terus, just multiply straightforward. So we just concentrate on only the open loop. Okay. Okay, so this is what we try to concentrate on the root locus. Okay, root locus only the analyze the system by using the open loop transfer function. So this is our system. So our system is K over S plus 1 multiplied by S plus 5. So the step of 1, Okay, step of 1, if you can see, we try to looking the number of the root. Okay, for example, now if you can see here, saya boleh cunting tak boleh. Okay, if you can see here, kalau kita lihat kat sini, okay, we have k over this. Okay, s plus 1, s plus 5. So now this, okay, numerator we call 0. This is the root of 0. This is the root of the pool. Pool. So if you can see here, we don't have any zeros. We only have the value of k. So none. So our 0 is none. But for pools, rule of pool in this system, we have 3 rule. We have 3 rule. Root, which is s, we have 0, s equal to 0, s equal to -1, and s equal to -5. So mean we have 3 value in pool. Okay, so what we
sorry,
can...
Doctor.
Sorry, yeah.
Some students are asking to join the meeting.
Boleh. Okay. What you want to ask?
They want to allow and they want to ask Doctor to allow them to join the meeting.
Tak dengar Hello?
They can't join the meeting. Some of the
Okay.
students.
Nak join lagi. Ya Allah.
Yes.
Sekejap saya tengok. Masuk lambat ni. Mafia betul lah kawan awak ni. Okay. Tak apa. Oh, patutlah. Okay, baik. Thank you. Okay, mana tadi? Baik. Okay. Alright. So, apa kita nak buat adalah, what we can do now, we try to draw. Okay, draw root locus. So, the drawing of root locus based on the S-plane. S-plane So, jadi sekarang ni, if you can see here, kalau kita lihat kat sini, if we can draw the root locus, okay, based on the, tak cantik sorry not good. Okay, so now we concentrate on the S-plane. S-plane. So we have only 2 axes, okay, which is we have the real and we have the imaginary. Axis. Okay. So if you can see our system, if we have k, g, h is equal to k, we have s plus 1, and also we have s plus 5. Okay, and we learn before, okay, kita dah belajar sebelum ni, the symbol of this 0, if we have the value root of 0, the symbol is kosong, 0. But if symbol of the pool, we need to cross. So x, x. Okay. If you can see here, this system, okay, we don't have any zeros. Okay, k is not zeros. K is the value of gain. So now we don't have. Tak ada lah. You can put tiada or you just leave it. Ataupun letak kosong. Tak, you cannot put 0. Mean if you put 0 means they have the value. Jadi tak boleh. You cannot put any number. You just leave it. Ataupun just nak letak none ke apa ke. Okay. So tak adalah, biar je. So if we try to concentrate on, alamak, apa pula ni? Okay. Kenapa tak boleh? Alamak. Kenapa? Okay. Awak dengar tak? Tapi saya tak boleh. You can hear?
Yes.
Boleh Okay. Wait anything happen, you just stay. Okay, just stay. Nanti saya akan masuk kata kalau hang ke apa, saya okay boleh. Alright, boleh. Alhamdulillah. So jadi now, okay. Kadang-kadang dia tak boleh lah. Ini saya duduk kat rumah pun, internet pun macam duduk kat dalam. Sekejap. Okay. So now this is 0. We don't have any zeros root. But if we think about pool, we have 3 pool. We have 0, we have -1 and -5. So we have 3 pool. So, okay, we need to put these root into the our S plane. Okay, so now 0. 0 you can put cross as a symbol poles, and also we have -1. For example, now this is 1, this is 2, this is 3, this is 4, this is 5, let's say. So now we have -1 and also -5. So we have 3 3 root of the pool. We don't have 0. Okay, for example here. So the step 1 as well, they mention they have branch. Saya tunjuk sikit. Okay, they have branch. Okay, they have branch ada kat sini Okay, they have branch or real axis segment are to the left of the odd number of the real axis finite pool and 0. Apa ni? Okay, what is this? This is like this. Okay, for example, in this point of the real axis, we have three value. This is the value of number 1. This is the value of number 2. And this is the value of number 3. In terms of the value is 0, -1 and -5. But we are considered as the number of value. So we have 1, 2, 3. So the branch, the real is means if you draw the dia call apa dia panggil tadi, some book use branch, some book use real axis. Okay, tak apa. Okay, the real axis akan terletak di sebelah kiri odd. So means we have 1, 2, 3. Okay, 1, 2, 3. Means 1 is odd, it will be go to the left. So jadi kita ada satu garisan. Nanti awak kena tanda kat sini. So once you answer the root locus sketching, you need to involve several color. Maksudnya adalah you can use the color line untuk linekan. So we have this line because of odd nombor ganjil. We have number 1, number 2 and number 3. Number 3 odd. So mean the left. Kita ada kat sini. Okay. Okay. So step 3 or step 2. So first step is to consider the value of the pool and 0. Second is to come up with the put the value in the S plane. Kita dah we put into the S plane. Okay, and stage 3 is to show the line real axis, okay, in this particular system. So means that the real axis it will go to the left. Maksudnya yang kita ada ni. Katalah contoh. For example now, for example we have this. Okay, another example. So we have real, we have the imaginary. Okay, example we have, for example, let's say we have maybe here. Okay, for example here. Okay, let's say our system is like this. So we have, okay, it doesn't matter about the value. Now we are trying to count, okay, how many pool and 0 on the line of the real axis. So we have 1, 2, 3, 4, 5. So means that number 1 is the odd. So the line real is go to the left. On the left. Okay, this is 1, 2, 3. 3 here. Sampai sini. 4, okay, ganjil. 5, odd. So here. Ada soalan tak? You have any question? Now we are in stage 3. Stage 1, looking for the symbol of the pool and 0 in the locate into the S plane. Number 2 is the to draw, okay, based on the S plane. Number 3 is the align of the real axis.
Tak faham betul step 3.
Step 3 ni maksud dia macam ni. Step 3 ni adalah kita nak buat line. Okay, kita dah ada point. Okay, step 3 ni bermaksud dia nanti dia ada garisan. They will go align macam ni contoh sekejap saya cerita. Kejap. Macam mana nampak ni kejap saya ambil satu contoh kejap. Okey kejap okey. Kalau kejap saya tengok. Sekarang ni apa kita nak buat adalah kita nak come up with the sketching by using root locus. Root locus is try to show to us the performance of the signal, okay, in this system. They have some consideration to design the root locus. So we have some stage ataupun we have some apa dia panggil rules to design the root locus. Okay, the first rule is to try to come up with, okay, kalau kita tengok ni the first rule is try to identify the pool and zero value. Okay, so now you done this. Okay, based on the rule 2, symmetrical on the real axis means that, okay, some book they have their different meaning, but the objective is same sama Rule 2 is to locate all the value pool and zero into the S-plane. So now you have done. Now you identify. You have done all the identify of the pool and the zero value. The second is you locate all the value. Okay, all the value are related to in the system to the S-plane. So dah letak dah kat dalam kita punya nilai-nilai tu. Kalau katalah we have 1 0 and 3 pool means that you locate 4 value into the S-plane. So come out. Okay, root 3, okay, dia kata apa? Rule 3 ataupun stage 3, they mention real axis segment are to the left of the odd number of the real axis finite pool and zero. Means that they have one line, they will a curve ataupun dia akan ada, they will appear a line will be appear, okay, they will appear ataupun will be come if we have, okay, if they will come on the left on the odd number. Odd number means odd number dia adalah contoh macam ni. Even we have the value 0, we have value of -1, value of -5, but we need to count the number on the line of the real axis. Mean here, we start from the 0 is locate as the number 1. This is the locate as number 2, and this is the locate as number 3. So in this system, we have 3 point. 1 point odd, second ganjil kita punya ni, third is odd again. So means kalau kita punya number, if we have the number is odd, means they have a line in the left. Maksudnya kalau kita ada number ni, kita locate ni kat sini, kita lah nombor 1, nombor 2, nombor 3. Nombor 1 ni mesti ada line. Tu dia punya, this is the root atau rule ataupun dia punya dia punya konsep. Boleh? Sebab apa nanti kita akan lukis ni. Benda ni dia ada konsep dia. Kita hafal je dulu yang ni. Ataupun kita imagine that we follow, okay, what they want. Nanti bila later nanti kita akan lukis guna MATLAB. We will design this use MATLAB. Then they will show us. So if we straight go to the MATLAB without any theory, awak tak nampak. You can see what happened. Now we try to come up with one by one using the manually sketching root locus. Tak boleh. Padahal kalau dalam real world, kita dah lukis je terus. We come up, we use the MATLAB, then MATLAB will be appear ataupun we will show the graph, the real graph on the root locus. Based on the, okay, based on this system, this is the root locus figure. But as an engineer, we should know the theoretical. So where the theoretical come from, this we need to understand the stage of design of the root locus. Benda itulah. Jadi yang faham tak? Maksudnya line ni akan terbentuk bila benda ni akan ada di nombor ganjil. Dia akan terbentuk di sebelah kiri pada nombor ganjil. Bukan the value, this is not value ganjil. No, the mark as the number of the value. This is number 1, number 2, number 3. So we have 3 value. We have 3 number, but the line will be go to the left on the number odd. Maksudnya tu. Boleh tak? Siapa tadi tanya tadi?
Okay.
Boleh lah, boleh Okey, ada soalan tadi, jap saya tengok. Ada tak? Ada siapa-siapa tanya ke? Dia student asking to join meeting. Dah tadi dah ada Ke dah saya tak ni? Tadi dah Dah Okey dah, baik. Tak sempat nak tengok tadi. Okey, baik. Okay, so this is the concept step 1, step 2, step 3. Okay. Kita tengok balik step 4. Okay. Ni real life begin. Okay, yang tadi. Okay. Apa kita nak buat adalah, okay, what we can do now, okay. We have okay, kalau if we have pool, so kata kita ada pool, so they have arrow. Maksudnya they have arrow. They have arrow come out. Maksudnya kalau kita ada pool, arrow. Kita kena ada arrow. Kalau kita ada 0, okay, maksudnya no. Okay, for example here. Sekejap saya tunjuk. Kalau if we have this, okay, so we have go to the arrow. Arrow must be come out from the pool. Maksudnya kita kena letak lah. We need to put arrow in front of our pool. 0 tak ada masalah. So if we have this, for example, 2 pools means that we have 2 arrow. Okay, 2 arrow. Ni sambung Okay. So next step dia kata, next step apa lagi? Saya tengok kat sini. Sebelum kalau apa-apa tanya je. Saya tolong. Dia kata mana lagi? Kita dah ada. Kejap. Okay. Kita ada next step. Okay. Next step is to produce the asymptote angle. Okay, asymptote angle. So number 4. Number 4, step 4. Okay, saya step 4. Step 4 ataupun rules 4 Okay, kita nak cari, we are looking for asymptote. Pula macam this is istilah istilah, jangan risau sangat. So asymptote angle. So they have the formula. The formula is 2 times of k plus 1 multiplied by 180, and we have p minus z. Okay, so and k ni, the number of k ni is the, okay, start from 0, 1, 2 and so on. Tak ada masalah, it depends. Okay, tak apa, kita tengok. Okay, step 4 is to define the asymptote angle. Sebab apa tahu? Asymptote angle ni, this is the sempadan. This is the boundary of this system. This system. Okay, kalau kita tengok kat sini. Tengok saya conteng dulu. Okay, if you can see this. Okay, this is the another example, but we try to get to understand on this what happened in this behavior of the pool and 0. If we have pool and 0, it doesn't matter. We have the arrow and go to the pool, means 0. We have pool and 0. Okay, enough. We have female and male. Okay, but if we have pool and pool, means that, okay, we have arrow and arrow. Basically, okay, it will go to somewhere. Maksudnya kalau ada anak panah ni, dia akan keluar. They will go out. Tapi nak go out mana? So maybe they will go here, Maybe they will go here, maybe they will go here, maybe they will go. Kita tak tahu, we don't know. Okay, but the programming dah tunjuk dah, show. But in terms of the theoretical, we need to find. Now, we try to looking for the asymptote angle. Asymptote angle is boundary. Maksudnya kita kena cari dulu boundary dia. So now we are locate to the boundary. Maybe we are maybe the location of the boundary is something here, and then we need to clear ataupun we need to define the boundary. Okay, maybe here. So means that maksudnya kalau kita ada, if we have this boundary means our line only go to the light. Maksudnya dia akan pergi sini je lah, dia tak pergi. So maksud ada sempadan. Minta maaf lah. So benda ni kena tengok juga satu-satu. Sedangkan indirectly you can draw, you can use your software, then software will show everything here. But as an engineer you should know the procedure how to design this. Kena buat, maksudnya tak boleh, sebab you need to design after this. You need to design this system to get the to get the achieve objective, our objective. Our objective. Jadi sekarang ni kita nak tengok asymptote. Asymptote this is our asymptote formula. So our asymptote formula is 2k plus 1 multiplied by 180 over p minus k. Based on our case, this case. So sekarang kita nak tengok. Sekejap. Kita nak tengok. We are need to calculate this. Saya padam ni dulu. Allah. Saya buat ni dulu. Tak boleh padam. Tak boleh padam. Tak boleh Tak apa. Saya buat sikit. Tak apa, buat sesuatu Okay, kita tengok ni. Okay, sekarang ni we are try to do some analysis on asymptote angle to define the value of the asymptote angle. Okay, so so now we have asymptote angle. Asymptote normally I use AS. Asymptote angle I use AS, or you can use AA, anything. You have plus 1 180. So P is the number of value pool. So in this case we have 3. We have P is 3, Z is number value is 0. We don't have any value of Z, so 0. We only have 3 root of this pool. We have number of value of pool is 3. So now we have 3 minus 0 means here we have 2k plus 1. So we have 180. We have 3. So here we have 2k berapa? 60. Betul? 60. So we have 60 multiply 2k plus 1. So now K must start at 0 until go to higher number. So now we have start from K equal to 0. So start from K is 0. See, our first AA is we have 60 degree. So if we try to substitute K equal to 1, we have our A mean berapa? So kita ada 180 degree. So if we have K equal to 2, so we have AA is 300 degree. But if we try to substitute K equal to 3, it go to berapa? It will go to around lagi. Maksudnya dia akan balik semula kepada berapa? Kalau 3, so we have 6, 7, kita ada berapa? 7, 420 means that sama dengan 60. Sama. Kan? Dia tak payahlah. So enough. We only we only show the k equal to 0, k equal to 1, and k equal to 2. Means that we have 360 degree. In 360 degree, we only consider as 60 degree, 180 degree, and 300 degree. Yeah? Okay. So where is they locate? So maksudnya kita dah dapat dah. We have to identify the asymptote angle. We have 3 asymptote angle in this particular case here, but we need to come up with the location of this asymptote angle. So this, to find the asymptote angle, saya tulis balik. Okay. So apa kita nak buat adalah, what we can do is we need to create ataupun we need to follow the step 5, which is we need to define the point intersection of the asymptote intersection of the asymptote angle. So jadi kita nak kena cari. So normally we call CG, center gravity of the asymptote. CG, the value of CG ataupun the formula of the CG, center gravity, is we have the formula of this. Mana pula formula dia? Kita ada, we have the summation of pool minus summation of 0 over P minus Z. P minus Z. Okay. So the summation of value of pools minus summation of value of 0 over number of pool minus number of 0. So in this case, we have the value are related to the pool is we have 0, okay, plus minus 1, plus minus 5. Okay, so we have negative, so we don't have any 0. So 0 lah, tak ada lah, sini tak ada lah. So we have 3 minus 0. So we have negative 6 over 3 and we have negative 2. So this location, okay, location of the asymptote angle is represent the value of negative 2. So from here, okay, inside here, maksudnya in the based on the S-plane, apa kita nak buat adalah you need to mark, okay, our negative 2 as the intersection ataupun the location where is the asymptote will be occur, maksudnya berlaku. So jadi negative 1 and negative 2. Saya buat warna lain. Katalah warna purple lah. Okay, this is number, this is negative 2. Ini negative 2 So now we all have 3 angles, 60, 180 and 300. So use your projector ataupun jangka sudut apa tu. Okay, use your ni, kena bawa in your final you need to provide projector and then so on yang kita buat tu. So jadi 60 degree. So for example here 60 degree, you just come up with the 60 degree, use your jangka lukis tu, jangka sudut tu. Okay, projector, then you will get 60 degree here. This is one asymptote which is represent as 60 degree, and then this is 180, never mind, is on the line, and also we have 300 degree, sorry, okay, here like this, sorry, sini. Okay, sini. Okay. Okay, ada soalan tak? If you have any question to ask regarding the step 4 and step 5. Ada? Step 1 is to find the value of the pool and zero. Step 2 is to locate all the value are related zero and pool into the S-plane. Rule 3 is to show real axis or line, we be left on the odd number of this real axis to number 3. And number 4 is to find the asymptote angle on this case. So we follow the standard formula, which is we have 2k plus 1 multiplied by 180 over p minus z, means that the number of the pool minus number of zero. So in this case, we have 3 angle, 60, 180 and 300. And to find the location of the asymptote angle, we need to use this formula, which is summation of the value of pool minus summation of value of zero over number of pool minus number of zero. So we have negative 2. So here in this case we have negative 2, and then if you put mark as the negative 2 here, then you need to use your projector and so on to show where is the boundary of this asymptote angle. So we have 60, then you come up with the dash line here to show the 60 degree, and then 180, never mind, it doesn't matter. And then we have this 300 300 degree here. Okay, ada soalan tak? Kelas, ada apa-apa soalan nak tanya?
Doktor.
Ya.
Kalau yang anak panah tu ada lebih daripada satu, anak panah yang bertentangan tu ada lebih daripada 1 point, dia punya asymptote angle tu sama juga ke?
Ya, betul. Dia depend. Dia selalu normally asymptote angle ni only we only find the location of the asymptote angle only one time. Sekali je. Nanti later saya cerita dengan awak dulu. Nanti kan dia ada case lah, banyak case, there are a lot of nanti kita akan nampak lah dia punya exercise. Dia macam ni. Okay, this is your real, this is your imaginary. For example, this is for your example. Katalah kita ada ni, we have this and this and this. Okay, so maybe ni apa yang awak masukkan kan? Sekejap katalah here 1, 2, 3. So here this is the line of the left of the odd. This is line of the odd. So we have this, we have this, we have this, we have this. So once we we find the asymptote angle tu, some cases it will go to we have four angles. 4 angle. For example here, based on the system lah, normally you will get 60, 200 berapa? 60, 200 200 lebih lah nanti. Apa yang you will get this. Okay, for example, maybe this one is maybe negative 3. So you will get 4. Normally 4. For the maximum of asymptote angle, you will get 4 AA. Okay, so means you will get 60, and then we have this berapa? 100 berapa? 120 ke 100 macam tu. Then you have 200 ni, and then you will get this. Okay, macam ni contoh. Then this arrow, maksudnya anak panah ni, sebab dia bertentangan ni, they will consider as the arrow and arrow, they will go somewhere. So they will go out macam ni. Nanti selalu awak akan nampak. They will go out macam ni. Ni kan apa yang awak maksud kan?
Ya.
Ya, betul. Okay, you will see this example after this. Awak akan jumpa nanti. Sabar. Yang ni tak ada masalah. Nanti akan dapat ni. Yang penting, the important thing is you need to find the asymptote angle. to get the boundary first. Okay, so where they locate is you need to follow the step 5 to use the formula of center of the gravity. Okay, where is the point locate our asymptote angle. So kita dah dapat yang tu baru. So now the step is to ni lah, to define, to find where the line, our line ni real exit will come out. Maksudnya kat mana line ni akan keluar. Dia kat sini keluar ke, kat sini keluar ke, dia will go out ni ke kita tak tahu. Ini kita nak kena kira. Ni step 6. Step 6. Ada orang nak masuk ni ke? Ada orang nak masuk dah nak habis lah. Macam-macam awak ni. Okay, tak apa. Kita layan aja. Okay, ada soalan lagi? You have any question about this? Ada tak? Tak ada? Boleh saya continue? Okay, nak continue? Okay, good. Okay, so sekejap kita tengok. Okay. So we have now, if you can see here, we have pull and pull, and this is pull alone, never mind. So we have this asymptote as the apa dia panggil sepadan boundary. So we have this boundary for 60 degree and we have another boundary for 300. So means that this two pull it will go to somewhere. Maksudnya this line it will go out. Maksudnya dia will go out lah. Maksudnya nak cari nak dapatkan nak keluar tu kat mana. Where they will the point this line will move on. Atas bawah ni kat mana. So we follow the rule ataupun step 6. Okay, step 6. So we have step 6. Okay, they have formula to define the point where is our real exit will go. Okay, go out. Maksudnya keluar. Nak capah ni. So jadi the formula for this to define as the point where we have summation, ni pening sikit. Summation of 1 over mana formula dah. Okay. Summation of formula we have ni sigma B minus PI equal to summation of sigma B minus ZI. Okay, so means this is formula where we need to define the value of sigma, where this sigma it will show us the point where our line ni keluar, move. Okay, this is step 6. Okay, so this formula are represent as 1 over sigma. Okay, this summation of sigma minus value of related to pull equal summation of 1 over sigma minus the value are related to 0. Okay, now in this case, our case, we only have 3 pull. So means that we have 1, we have sigma B minus 0 plus sigma B minus 1. Betul? Okay. So plus apa lagi? So we have sigma B minus 5 equal to 0 sebab we don't have this any related value of 0. Tak ada, kita tak ada. We don't have. Okay, so we don't have this. So now use your mathematic experience. Macam ni kita gunalah mathematic channel, buatlah macam mana magic pun. Nanti awak akan dapat lah. So nanti you will get, saya rasa lah you akan dapat B plus 1 lebih kurang lah plus 5 sigma B campur 5 campur dengan sigma B campur 1 sama dengan kosong. Ini naik ni, all this go to 0 lah. So nanti you settlekan yang ni. Tolong saya apa-apa. So jadi you will get sigma B kuasa 2 bla 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 equal to 0. Okay, tolong. Okay, berapa? Sigma B square apa? 2 sigma B kot 3 ke? Tak ingat. Abdul Rahman, please help. First. Berapa kelas? Tolong.
3 sigma B square.
Okey, siapa tadi? Ni siapa ni? Boleh saya tahu? Apa?
Nurin Adriana.
Nurin, okey, baik Nurin. Okey, we have Allah. Kejap. We have kita ada we have 3 sigma B square
Tambah 12 sigma B.
Sigma B
Tambah 5.
tambah 5 equal to 0. So from this, carikan faktor kan. You need to factorize this. Use your calculator. Terus je guna calculator. Then you will get the two number. Sigma B, berapa dapat? Lebih kurang? Ni. Guna terus calculator je. You will use direct your calculator. Or you
Negatif 0.47.
Negatif, kejap negatif, sekejap saya tukar warna bagi nampak sikit. Tambah. Boleh dah. Kita ada negatif kat sini, negatif
0.47.
0.47, satu lagi.
Negatif 3.52.
52. Okey, 53, 52 tu lah. Okey, terima kasih banyak-banyak. Siapa ni?
Taufik.
Taufik, baik, terima kasih Taufik. So sekarang ni, we have two value which is 0.5 approximately 0.5, and then we have negative 3.5. Okay, so from based on this figure, okay, kita ambil yang reasonable. Maksudnya kita ada, we have 0 to negative 1, means that our suitable point is negative 0.47. Jadi awak akan tunjuk kat sini. For example, here is like somewhere here lah, negative 0.5 here, and then 0.47 here. Okay. Okay, now follow the rule step 7. Step 7 tak ada dah kat sini, tak penuh. Sekejap saya kena ni sikit lah. Okay. Okay, buat sikit jahat sikit kat sini Okay. So saya nak guna kalau apa kita nak, katalah kita buat ni lah. Okay, boleh, tak ada masalah, kita buat ni lah bagi nampak. Okay, step 7 dia kata apa? Step 7 kalau ikut buku lah, mana-mana tak apa, tak ada masalah. Dia kata sekejap, step 7 mana step 7 dah tak keluar. Okay, dia kata kalau dalam ayat panjang, dia kata the locus leave or approach the real axis at the angle of plus minus 90 degree. Means, okay, apa yang kita nak buat adalah bila dia keluar tu, okay, locus leave, kita tulis sini locus, saya terus buat ni, locus tinggalkan dekat leave tu ataupun approaches, okay, Saya buat sini plus minus 90 degree. Mean, okay, apa maksud dia adalah kita dah tahu dah, we know the location, the point of this alpha B ni, and then they will go, they will leave, go out lah ataupun go down lah, must be negative or positive 90. So maksudnya awak buat je syarat. So jadi maksudnya here is go to here. So mean this is 90 degree. That's it. So okay, sampai mana? Where? Sampai where? Maksudnya sini. Dia akan pergi. They go out. Untuk theoretical, Theoretical, it will just follow straight forward, straight, go to this 90 degree until, okay, approach the boundary ni, it will go follow the boundary sama. And also down go same what we did in upper. So jadi dalam bawah atas pun sama, dia akan go sini. Okay, dah selesai ni. Selesai, finish, but okay, this is the this is root of number 7. Okay, now roof ataupun step number 8 is to looking for the in this intersection. Bermaksud apa? What that means that our system, it will go to the unstable condition. Maksudnya kita nak dia akan pergi ke sini. They will go to our area unstable. Unstable. Jadi kita nak tengok, we need to looking for the value of the critical point in this intersection. Jadi untuk step seterusnya, the next step, the last step is to looking for the value of this intersection. Okay, ada soalan tak setakat ni? You have a question so far?
Doktor, kalau dia punya line tu ke kiri, tak intersect dengan imaginary tu, tak ada value lah.
Tak ada value, betul. Some cases they have no value, but some cases ada value. Depend pada asymptote. It depend. Tu sebab tu kita kena we need to find the asymptotes first. Okay, ada setengah kan. Nanti kita akan jumpa lah benda-benda macam ni. Tak apa. Kurang-kurangnya nanti kita akan buat lah latihan. Dia ada setengah, some cases it will get like this. Kita ada macam ni. We have this is our line. This is line. Okay. And also, okay, our asymptote, okay, based on the calculation, it will go like this. This is our asymptote. Ada juga. Okay, so mean we go to kita find the step 6 to find the sigma b, and then we get the value of sigma b, and then it will go to up 90 lah. It go to 90 sampai habis. Jadi bermaksud kat sini sistem kita good. Good means in this stable area. Yang risau dia adalah what we need to consider is they will go this. They will go like this. Bila go like this ni, maksudnya nanti later after this chapter we need to design some controller, okay, to restructure this line. Must go to like this. Kita nak buat macam ni. Nanti later. Nanti. Setakat ni, from now we only show where our system go. Maksudnya kat mana je dia pergi. Tak apa, biar dulu. Nanti later, the last chapter, we need to design this. To design this, make sure that our locus, we go to somewhere around this. Maksud kita nak ni, surround kat sini. Kita tak mau dia lintas ni. We not allowed, okay, this our system cross to the unstable condition. Boleh ke lah?
Boleh.
Baik, terbaik. Okay, so now apa kita nak buat adalah, okay, so now we are looking for this value, intersection value this. Okay, boleh. Mana lagi? Okay, ni here. Okay, so this is step 7. Okay, Dia ada step, dia until step 9 lah. Selalu it depend the cases lah. Depend cases Sekejap saya buat dulu. Sekejap. Okay, so now step, kita ada panggil ni kita step 8. Okay, step 8 ni dia lain. Step 8 ni different cases Nanti kita pending dulu, we hold this. Okay, but I will tell you, kena cerita juga apa yang akan berlaku dekat step step 8 ni. Step 8 dia macam ni. So now we have this S-plane R imaginary. Apa kita nak buat adalah some design. Kita ada satu sistem. Okay, macam ni. Kita ada, we have KGH is equal to we have, let's say S plus S square plus 2S plus 2. Okay, so bila kita tengok kat sini, okay, for the pool itself, for the zero tak ada masalah. We don't have any zeros. But for our pools, we have 0 and berapa ni? So jadi kita ada, we have negative 1 plus J and also negative J. Betul? Negative 1J. Lebih kurang lah. Betul? Okay, betul ni. So jadi apa kita nak buat adalah, we have negative 0 here, but negative 1 here, and positive J and negative J. So we have, this is imaginary, this is J, this is negative J, this is negative 2J, plus positive 2J, negative 2J. So here, based on this faktor ni, apa kita dapat adalah root kita ni, root our pool, we have here pool and we have pool here. Okay, dia tak ada dekat, they are not touching on the line real, but they are in the middle of this exist imaginary and real ni. Apa kita nak buat? Step 8, they need to, ataupun we need to consider, ataupun we need to define the angle where they go. Maksudnya kita katalah kita dah ada ni. So we have, this is for example, this is our asymptote. Okay, ni our asymptote. Where they go? Dia nak ke sini ke? Dia nak go di here ke? Or they will go here ke? Or go here? But the step 8 is to define we call theta D. Theta D ni, okay, to define the value of theta D to represent as the, okay, where the angle go to. Maksudnya kat mana angle tu keluar. Dia akan keluar kat mana. So jadi dalam case ni nanti kita akan kira. Sebab dalam case yang sekarang ni, what the current problem now, we don't have any imaginary point. We only have the real point dekat sini je. Nanti later, the second untuk minggu depan ke, next week or this week, we will see the example of the imaginary point. Tu untuk step 8. Okay, but now we need to continue. We have state 7. Okay, we already know they will go out and go down is 90 degree, and then they will approach to the imaginary axis and they will cross to the unstable condition. It doesn't matter. After this, we need to control this. But for now, to fulfill our step, okay, procedure step, root locus, we need to consider step 9. Step 9 ni adalah to get the intersection, dipanggil get intersection. To get intersection. Maksudnya intersection apa? Ni section ni. Kita nak cari ni. Okay, dia have their formula. Dia nak formula dia. Formula dia apa? Formula dia, we need to come out with the quadratic equation. Maksudnya untuk step 9 ni kita kena guna 1 plus KGH equal to 0. Balik semula kepada hoof rate tu tadi yang kita belajar first perjumpaan, the first lecture last 2 week tu, how to come out with hoof rate kita. Maksudnya hoof rate ni table ni. Okay, nak tak nak kena buat. So now our case is, so we have 1 plus kgh. Okay, 1 plus kgh. Our system, what is our system? Our system is kita ada ni adalah sama dengan K S campur 1 S campur 5. So we have this. So if we have 1 plus K, ni K lah, tak ada masalah lah. KGH equal to 1. Jadi apa kita nak? 1 plus, kita ada K, kita ada S plus 1, S plus 5. So apa kita nak buat adalah kita nak cari dia sama dengan kosong. So now we have S, okay, S plus 1, S plus 5 plus K equal to 0. Dapat ni masuk dalam ni. So we have S power of 3, S power of 2, F power of 1, F power of 1. Kita kena buat. Okay, tolong saya buat. Okay, so please ni derive this equation and then input into our benda ni. Okay, apa dia nanti kita buat sama-sama. Okay, buat ini siapa boleh dapat. So jadi kita ada berapa S kuasa 3 berapa tak ingat dah. Sekejap. Saya nak buat kat mana Sekejap. Saya buat dekat Allah. Saya buat kat sini. Sekejap. Okay, sekejap. Saya buat kat sini buat part lain. Kita ada S plus 1, S plus 5 sama, plus K sama dengan kosong. So jadi S kuasa 3 campur dengan berapa? S kuasa 3 kita akan ada 6. 6S kuasa 2 campur dengan betul ya? Jadi 6 campur dengan 5S campur dengan K. Betul ke? Kuasa 6 5. Kuasa macam betul tapi tak tahu. Okay. Betul? Betul ke? Betul. Baik, terima kasih. So jadi kita ada ni. So we have this characteristic equation. So come up with this table. S power of 3, S power of 2, S power of 1. Okay. So jadi F power of 0. So kita masukkan. We need to masukkan. Okay, kita ada 1. Betul lah, 1, 5, 6K. Betul? Okay, so jadi kita akan cari B1, B2, C1, C2. Okay, so tolong kita buat balik elok-elok. Pastikan soalan ni full mark. Okay, question 1, test 1 must be full mark. Okay, so B1 is 6 multiplied by 5 minus 1K over 6. So we have 30 multiply minus K 6. So this B2 tak ada lah, kosong lah. So C1 is B1 multiplied by this 6 multiplied by this over K. Kita akan dapat nilai K. Okay, betul? So jadi kena buat elok-elok. You need to understand ni 6 masuk sini. Masuk sini. So tu yang sebab tu that's why in test 2 they will ask you to find the roof rig stability first. And then you already provide this jadual table from this. Okay, once you solve, you want to solve to get this intersection, mana dia tah, this intersection, just reflect balik jawapan tadi tu, maksudnya guna balik, you use back on the, maksudnya yang A tu awak dapat balik ni. Okay, apa kita nak buat? Apa kita nak buat adalah once no need to get julat K, no need, we only use this. Okay, once you settle this, we only consider, ada soalan tadi ke ada orang nak masuk? Ada orang lagi nak masuk? Boleh dah, ya Allah. Okey, tak apa. Nak habis ni. Aduh, ya Allah. Macam-macam. Okey, tak apa. Jangan risau. Yalah. Okey, sekarang apa kita nak buat adalah, the objective in this case is to define the value of this intersection. Okay. Okay. But we need our table of the hurik tu, roof hurik ataupun roof array table. So from the roof table, we only concentrate on this sahaja, this line, the second line. Okay, ambil benda ni, take it. Okay, take it this figure. Okay, and we will get, okay, apa yang kita nak buat adalah we will get, okay, masuk balik, keluar balik ni, you need to come out with 6s square, okay, plus k equal to kosong. Okay, sekarang apa? Jadi sekarang ni kena cari k, nilai k yang kita cari tu, what the value, the maximum, the reservable k, so we need here. So apa kita nak buat? Kita nak buat adalah, if we can say 30 negative k over over 6 equal to must greater than 0. So we have k less than kita ada 30, betul? So jadi k must be kosong. So jadi kita ambil 30 ni. So we have 6s square plus 30 equal to 0. So s square, so we have negative 30 per dengan 6. And then we have s equal to 30.6. And then we have apa? Kita akan dapat berapa? Plus minus berapa entah j. Berapa j? Tolong. Ya ke? 5 kan? Ni ke 5. Kita dapat negatif 5. So 5, sorry. Ni 5. Plus minus berapa ni? So berapa? Plus minus, sorry. Kita akan dapat, we have negative 5. Negative 5. So now plus minus 5 berapa? 2 point something. 2.2 apa? 2.23 apa? Semua j. Tak tahulah ni apa? Please. Taufik, Ayuni, apa ni? Siapa lagi?
2.24.
2.24. So now from here, 2.24 means that our point cross section on this imaginary line is positive 2.24j, then this negative 2.24j negative. Finish. This is what you need to answer on test 2. For the final, we add something nanti later. Now, just concentrate on this. Please do some revision how to come up with the root array table, and then try to follow the step sketch on root locus. So we have 9 steps basically depend on our system. So now this is one example. So I believe if you come up with 2 or 3 example, you will understand. Selalunya senang lah benda ni, benda senang, tapi nak kena hati-hati. You need to be careful on the do some calculation. Normally yang ni calculation on this alpha ni. Mana alpha? Adalah alpha tadi tu. Alpha ada. Oh silap. Okey, ada alpha ada. Tak ada bawah Okey. Alpha B tu selalunya kat situ mistake. Tapi tak apa, nanti we will do some more exercise to familiar on this all the problem statement, the focus on the how to sketch the root locus. Ni je untuk test 2. Yes, finish on this question 1 for test 2. So we have roof hurik array criteria, and then you have the root locus. Okay, kalau kita lihat mana lagi, tak payahlah, nantilah soalan nanti I will give the example of question test 2, and then at least you come up with the procedure how to get value on the every step procedure. Ada soalan lagi tak? Kelas?
Doktor.
Ya.
Untuk yang bahagian yang cari S tadi tu, kita guna yang S kuasa 2.
Ya, betul. Every time. So once our locus go to passing the imaginary axis tu. So we always concentrate on S power of 2 ni. So then kita akan dapat the value S plus S square plus anything, lepas tu equal to 0. So jadi yang K ni normally we come out, kita akan use the maximum ataupun the value reasonable on this range of K yang kita dah buat sebelum ni. So kita ambil lah sebelum ni, kalau kita lihat kat sini, the range of our K is greater than 0, less than 30. So okay, we put as the 30 value because of this is the critical as well. Jadi kita ambil 30 ni, then kita come out with this ni lah, looking for the S imaginary. Tak ada apa dah lah. Selalu memang akan ambil S kuasa 2. Memang kita kena ambil selalu. Even we have S power of 5, we are looking for the S power of 2.
Okay, Doktor.
Baik. So ada apa-apa soalan?
Doktor?
Ya, boleh.
Saya nak tanya satu soalan. Saya masih tak faham kenapa K kita ambil 30?
30 sebab, okay, because of this is the range of K. We have range of K less than 30 and also greater than 0. Means that, okay, if we are consider 30 as the critical value. Once we use 31 value of more than 30, 31, 32 means that our system is non-stable. If we are looking for the 30 means that it's 50-50, betul? Jadi dalam kes ni, apa kita buat adalah, okay, in term of this system, we know that our system also 50-50. Means that kita consider as the K as the 30 because of their in the critical value and the critical boundary of the imaginary axis. So kita tak ada pilihan, kita ambil 30. Boleh?
Boleh tak?
Boleh, baik. Ada soalan lagi?
Doctor.
Ya, boleh.
C1 equals to K.
How do you get C1 equals to K?
C1 is good, Masya Allah. What is name? What is your name?
Darrow. No. I just I can't seem to find the
C1. Okay,
Yeah.
the formula of C1, B1 multiply by K. Agree? Minus 6 multiply by B2. B2 0.
Yeah,
Over
because
B1.
I got stuck at B2. I thought there's a value at B2. So,
B2 no,
yeah.
because if you're looking for B2 is B1 multiply by 0 minus 6 multiply by 0 over B1. So you should get 0. Normally kalau sini kosong, if you have this right hand side 0, mostly this value B2 C2 is mostly 0. Tak ada masalah lah. If we have some value here in this first row, yes, they will have the value. Okay, for C1 is B1 multiply by K minus B1 multiply by K minus 6 multiply by 0 over B1. So B1 slash B1 you will get K. Nah, boleh Boleh Darren apa nama tu?
Boleh.
Boleh, baik. Ada lagi? Abdul Rahman, you want to ask something? Siapa lagi ni? Diam je ni. Diam. Nanti dekat nak ambil markah baru cakap-cakap. Baik cakap sekarang. At least saya kenal siapa dia. Tak apa, aktif je. Siapa nama ni? Syah Irdrawan. Ini banyak orang Sarawak ni. Lim, Sarawak Lim. Zikri, ada soalan? Lee, Jacob, Fatihah, tak ada ni, sarapan lagi mana-mana dia orang. Aaron, tak ada, okey. Ya, Syah apa? Nak tanya apa? What you want to ask? Syah Indrawan. Lau? Lim ada dua. Lim Jing dengan Ling Ka. Li Kan Kang. Ling Jing Yang. Ling Jung An. Tak ada soalan. Danish? Amir? Hamzah? Nur Ain? Nur Ain. Ayuni dah tahan cakap. Nur Fatinatul? Nurin tadi. Nurul Jana. Pergi. Sarah. Sarah? Ada? Okey. Taufik ada Taufik? Tarik? Tarik. Okey. Tarik, you want to ask something? Tarik bukan Tarik dia tanya. Tarik boleh saya kenal awak ni. Wafi? Tak ada. Okey. Okey, last soalan. Ada soalan lagi tak? You want to ask? No, thank you. Okay. Zulfahli? Tak ada. Tak nak markah ni dia orang ni. Tak aktif kan. Awak ni. Taufik ada Taufik? Awak nak tanya kan? Awak aktif Taufik?
Tak ada doktor. So far okey
Tak
lagi.
ada ya? Awak telat. Awak ketua kelas You are head of this.
Tak.
Tak ada Okay. Okay. So tak ada kelas. I will give okay. Example. At least you can do by your own. If you don't understand, you will ask. You will ask in our group. Anything. I will help. InsyaAllah. So thank you very much. Assalamualaikum.
Thank you doktor.